For billions of years after the Big Bang, the entire universe was wrapped in a darkness so total, so absolute, so suffocating that not a single photon of visible light could travel through it. No stars. No galaxies. No light of any kind. Just an endless, impenetrable fog of hydrogen gas stretching across billions of light-years in every direction, a cosmic blindfold so thick that even if you had been there with the greatest telescope ever built, you would have seen nothing but blackness. Scientists call this terrifying era the cosmic dark ages. And for decades they have asked one burning question: what was the first object powerful enough to pierce that darkness and end it forever? The James Webb Space Telescope has now found the answer. And what it discovered on the very edge of that darkness, in a galaxy so ancient its light has been traveling toward us for 13.4 billion years, did not just stun scientists. It shattered the timeline of the entire universe, rewrote the chemistry of cosmic history, and forced every textbook on Earth to be reconsidered from the very first page. Stay with me. What you are about to hear is real, it is verified, and it will change how you see the sky above you tonight. To understand why this discovery is so extraordinary, you first need to understand what the cosmic dark ages actually were, because the name barely captures how alien this period of history truly is. After the Big Bang, the universe was like a hot soup of particles, protons, neutrons, and electrons. When the universe started cooling, the protons and neutrons began combining into ionized atoms of hydrogen and helium. These ionized atoms attracted electrons, turning them into neutral atoms, which finally allowed light to travel freely for the first time. NASA science, but here is the terrifying part. That moment when light could first travel, called recombination, happening 380,000 years after the Big Bang, did not bring the universe into brightness. It brought it into a different kind of darkness. Scientists do not know exactly when the first stars formed or when the reionization process started. The emergence of these first stars marks the end of the dark ages in cosmic history, a period characterized by the complete absence of discrete sources of light. NASA science: for perhaps 100 to 200 million years after recombination, the universe sat in profound darkness, transparent but empty, clear but lifeless, waiting for gravity to slowly, painfully, pull hydrogen clouds together until they ignited. Then, perhaps 100 million years in, everything started to change. Over the next billion years, the universe went from a bland, unimpressive landscape to a rich and dynamic one. Astronomy.com and James Webb has now seen the very moment that change began. In April 2025, published in the journal Nature, an international team of astronomers led by Joris Wittstock of the University of Cambridge announced one of the most extraordinary astronomical discoveries in human history. Using the James Webb Space Telescope, they identified a galaxy so ancient, so impossibly remote, that it exists at the very boundary between the dark ages and the first light, and it is doing something no other galaxy at this distance had ever been seen doing before. A new discovery by NASA's James Webb Space Telescope has pushed forward the confirmed end date of the cosmic dark ages by some 270 million years. The galaxy, designated JWST Z13-1 LA, is so far away that the light from it takes some 13.4 billion years to reach us, meaning we see it as it was just 330 million years after the Big Bang. And from this galaxy, the team detected a signal of reionization, the process through which the first stars made the universe once again transparent to light. Newsweek: this is staggering. This galaxy is not just old. It is not just distant. It is actively doing something, pouring out energy so extreme, so ferocious, that it is tearing apart the neutral hydrogen fog of the dark ages around it, carving a bubble of transparent plasma in the cosmic blackness. It is, in a very literal sense, one of the first lights to pierce the darkness that had lasted since the dawn of time. Wittstock told Newsweek, this also suggests it has made an unexpectedly early start to cosmic reionization, the process where neutral gas between early galaxies is heated into a plasma by energetic radiation from stars and black holes forming in the first galaxies. But that discovery was only one half of what James Webb has revealed from this extreme epoch of cosmic history. Because just months earlier, in a discovery announced in May 2024 and dramatically confirmed with deeper data through 2025, Webb had already found something even more astonishing: the most distant confirmed galaxy ever seen by human eyes. Using Webb's NRSpec instrument, scientists observed a galaxy called JWST Z14-0 and obtained a spectrum of it that placed it at a redshift of 14.32, making it the current record holder for the most distant known galaxy. This corresponds to a time less than 300 million years after the Big Bang. NASA science: 300 million years. In a universe that is 13.8 billion years old. When astronomers first analyzed the data, they stared at it in disbelief. The NIRSpec instrument observed this galaxy for almost 10 hours, and when the spectrum was first processed, there was unambiguous evidence that the galaxy was indeed at a redshift of 14.32, shattering the previous most distant galaxy record. Science Daily. But the distance alone is not what stunned everyone. It is what this galaxy looks like. Because this galaxy, born just 300 million years after the Big Bang, at literally 2% of the universe's current age, is enormous, bright, and impossibly complex. In addition to being the new distance record holder, JWST Z14-0 is remarkable for how big and bright it is. Webb measures the galaxy at over 1,600 light-years in diameter, and the team says this large size means the light must be produced by young stars, not a supermassive black hole. UC Santa Cruz and 1,600 light-years across means hundreds of millions of stars, already burning, already organized, already structured, in the first breath of the universe's existence. Now here is where the discovery stops being merely extraordinary and becomes genuinely world-altering. Because when astronomers studied JWST Z14-0 in deeper detail, published in Nature Astronomy in March 2025, they found something inside it that should have been physically impossible. They found oxygen. And not trace amounts. Significant, measurable quantities of oxygen, embedded in the galaxy's interstellar gas. The discovery of substantial oxygen in the JWST Z14-0 galaxy suggests the galaxy had been forming stars for potentially 100 million years before it was observed. Science Daily. You need to understand why this is so shocking. In astronomy, anything heavier than helium is considered a metal. Such metals require generations of stars to produce. The early universe contained only hydrogen, helium, and trace amounts of lithium. University of Arizona News: oxygen does not appear in the universe by itself. It is forged inside the cores of massive stars through nuclear fusion. Those stars then have to live out their entire lives, millions of years, and then explode as supernovae, scattering oxygen across space. That scattered oxygen then has to be incorporated into the next generation of stars and the interstellar medium. This entire cycle takes enormous amounts of time. And yet here, in a galaxy existing at just 2% of the universe's age, we find it already done. George Rika, Regents Professor of Astronomy and senior author of the study, said, "It's a very complicated cycle to get as much oxygen as this galaxy has. So, it is genuinely mind-boggling." Science Daily. The finding suggests star formation must have begun far earlier than any model predicted, pushing the start of cosmic history back even further into the darkness before the Dark Ages themselves. And James Webb did not stop there. Because in December 2025, published in Astronomy and Astrophysics, came another discovery so precisely timed with all of this that it feels like the universe itself is forcing us to pay attention. An international team of astronomers achieved a first in probing the early universe, detecting a supernova, the explosive death of a massive star, at an unprecedented cosmic distance. The explosion occurred when the universe was only about 730 million years old, placing it firmly within the era of reionization. Phys.org. This supernova, designated SN in GRB 250314A, was first detected as a blinding gamma-ray burst, the most energetic explosion in the known universe, triggered by a dying massive star in the deep past. The supernova's brightness and spectral features closely resemble those of local GRB-associated supernovae, indicating that massive stars in the early universe may have exploded similarly to those today, despite the much lower metallicity conditions of the early cosmos. Phys.org. Think about what that means. The first generation of massive stars in the universe, born in the chaos of cosmic dawn, burning through hydrogen in only a few million years, died in explosions that look almost identical to supernovae we observe in the nearby universe today. The physics of stellar death did not change. The mechanisms were already in place, already working, already seeding the early universe with the heavy elements that would eventually become planets, oceans, mountains, and living cells. The universe was building the chemistry of life from the very first moments of its existence. Now here is a deeper layer of this story that most people completely miss, and it is arguably the most alarming finding of all. Because James Webb has not just found objects at the edge of the dark ages. It has revealed that those objects are doing far more than expected, and that revelation has created a brand new crisis in cosmology. Observations provided by Webb revealed that far more galaxies existed in the early universe than previously expected. These findings suggest that reionization should have ended 550 to 650 million years after the Big Bang rather than 1 billion years. But if this were true, the cosmic microwave background and the Lyman alpha forest would look different. There is a tension between these measurements and Webb's observations, what the team describes as a photon budget crisis. Universe today, in other words, Webb is finding so many galaxies pouring out so much ultraviolet radiation so early that the numbers don't add up with other measurements of the universe. The dark ages should have ended sooner than other data allows. Something is missing from our model. Even the faintest early galaxies that Webb has spotted are producing loads of reionizing light, 4 times as much as expected. Despite their dimness, there are enough of these galaxies to reionize the universe mostly on their own. Astronomy.com 4 times more light than any model predicted. From galaxies that are too faint, too small, and too early to have produced it. The universe at cosmic dawn was not a gentle awakening from darkness. It was a violent, explosive, overwhelming explosion of light and energy, far more powerful and far earlier than humanity had imagined. Stand back for a moment and take in the full picture that James Webb has assembled. In a period of just 2 years, through discoveries announced in 2024 and into 2025, this single telescope has identified the most distant galaxy ever confirmed, existing 300 million years after the Big Bang with hundreds of millions of stars and impossible amounts of oxygen already forged inside it. It found the galaxy that is actively piercing through the cosmic dark ages 330 million years after the Big Bang, pushing back the confirmed end of the dark ages by 270 million years. It detected the most distant stellar explosion ever observed from the era of reionization. And it revealed that the entire process of ending the dark ages happened faster, more violently, and far earlier than any physicist on Earth had predicted. NASA's own scientists stated that all of these observations together tell us that JWST 14-0 is not like the types of galaxies that have been predicted by theoretical models and computer simulations to exist in the very early universe. No suitable analogs have been found from hundreds of other galaxies observed at high redshift. NASA science: this galaxy is unique. It is unprecedented. It does not fit any existing category. And the deeper Webb looks, the more unanticipated findings emerge, with the team stating this discovery is likely to be seen as the most significant extragalactic discovery with JWST to date. UC Santa Cruz. We are watching, in real time, the complete reconstruction of the first chapter of cosmic history. Everything we thought we knew about how the universe awakened from its darkness is being rewritten, discovery by discovery, galaxy by galaxy, photon by photon. The cosmic dark ages lasted for perhaps 100 million years. 100 million years of absolute nothing, no stars, no light, no chemistry, no possibility of any of the complexity that eventually led to you sitting here watching this video right now. And then the first light appeared. Something ignited in the darkness. Something so powerful, so bright, so extraordinary that it began to tear apart the fog of the universe itself, and from that moment, everything became possible. Galaxies. Stars. Elements. Planets. Oceans. Life. You. And the James Webb Space Telescope has now looked back far enough to see that very moment with its own golden eye. Not predicted it. Not modeled it. Seen it. The ultraviolet light emitted by the first stars broke down the neutral hydrogen gas, filling the universe into hydrogen ions and free electrons, initiating the era of reionization and the end of the dark ages of the universe. University of Arizona News: we are the descendants of that first light. Every atom in your body was forged in stars that ignited when the universe first awoke from its darkness. And now, for the first time in human history, we can actually see the moment it happened. If that doesn't make you want to know more about this universe we live in, if that doesn't make you feel the weight and the wonder and the absolute privilege of being a conscious being in a cosmos this magnificent, then I don't know what will. Subscribe right now. Because every week on this channel, we go further into the deep sky together, and the universe is not done astonishing us yet.